Radicals. Okay, radicals are where we have this little thing that's like a little house that has a little hook there. So radicals, when you look at them, if there's nothing written, it's automatically a square. And then they have different, that square, or that 2 is actually called an index. And so we have different radicals with different indexes. So this is the square root, the cube root, the fourth root. And so what happens is that whenever I have a radical, let's say that I have an x in each one of these, in order to change it, it could be changed into exponents. And so the index becomes the denominator, and then the power is 1, so that's the numerator. So this one becomes x to the 1/3, this one becomes x to the 1/4, but these are how you change radicals. The index becomes the denominator, and the numerator, the exponent, becomes the numerator. And so if we had something, for example, the square root of x to the third, that is the same thing as x to the 3/2. And so that's just a general rule for exponents and radicals and the relationship between them. So for example, if I had a problem such as 81x to the fourth, if I had this problem, then what happens is that you make you could change this to 81x to the fourth to the 1/2, and then that we know that we have 9 squared, and that then becomes x to the 4 there, and we have to the 1/2 there. And we know that anytime that we are multiplying two things in the quantity, there cannot be any plus or minus in there, that anytime that you have that you are going to distribute the exponent to the other exponents. But that only happens when it's multiplied and not when you're adding. So when you distribute that, this is going to be over 1, that's over 1. So we end up with 9, 2 over 2, because when you multiply 2 times 1/2 becomes 2 over 2. And then you have 4 over 2. And so that becomes not 1 on there, and then that becomes x squared. So that's how you do it the long way with the exponents. If you're going to do it the short way, well, that's the rule that you want to change it. You know the index is 2, so it becomes 9 squared x to the fourth. And so what happens here is that the index cancels because of the reason up here. And so it becomes 9, and then the 4 and the 2, it's reduced because there are 2 there, and so that's coming from this information there. So that's really the short way, but the reason why you could do it is because of those rules up there. Now, if we have something that's another index, in this case, let's say that there's a 5, then we have the 243 x to the 5th, y to the 5th. So if you're going to do that, then what happens is that you want to try to make the coefficients in terms of a 5th root. That's your goal. Sometimes you could do it, sometimes you can't. In this case, you can, because it's 3 to the 5th, x to the 5th, y to the 5th. And so what you get there, and I think I wrote that wrong. It's 15 right there. So that's wrong. So that's a 15. But this one here has an index of 5. So if it has an index of 5, we know that 5 divided by 5 is 3. 5 divided by 5 is x. And then this one here, 15 divided by 5 is 3. So that's really your answer. But if you're going to do it the long way, you know that you're going to have 3 to the 5th, x to the 5th, and then y times y times y, and each one is 5 of them. It has a 5 because when I add these, remember when we're multiplying the same base, the exponents get added. So 5 plus 5 plus 5 is 15. So what you do is this one takes out 1 3, this one takes out 1 5 because they cancel, and each one of these is canceling, so then I have 3 y's left. And so that is where we get that part. And so looking at that, it's not so bad. There's different forms to see on there. So if I have a question like 3 and then I have x minus 9 to the 5th, that's the same thing. In order to add that, we're going to add them. I could change this. It's still the index of 3. Now this is treated, it's a quantity, so it's treated as one thing. But I could break it up to x to the third and then x minus 9 squared, because they are the same bases. So I add the exponent, and 3 plus 2 is 5. It's the same reason why it's up here. It's the same reason up here. It doesn't matter what the base is, as long as the base is the same. So when you do that, I could take 1 out of there, and so I get x minus 9 out, because the 3's cancel, and there's not enough to come out from there, so that one stays inside. So your reduced form is that. Another problem here, I think it's the square root of 25 x plus 2 cubed. Same thing. You want to have, it's going to be 5 squared, and then this one here is going to be x plus 2 squared, x plus 2, and that is all under the square root, so it's a 2. The 5 comes out because the 2 and the 2 divide. That comes out because the 2 and the 2 divide, and so the only thing left over inside is the x plus 2. So that's your answer there. Let's see another problem. Okay, so division is the same exact thing. So you still have an index. So you still have 64x to the, I think it's 4, and then over 343. So it's still the exact same thing. Just like distributing with multiplication, you distribute with that. So I'm going to do it the long way. So in this case here, I think it's 4 times 4, 16 times 4, 64, if I'm not mistaken. But let me check on that just in case. So we are going to see clear 4 times 4 is 64. Yes, I'm right. So it's going to be, and I think the other one is 7. So it's going to be 4 to the third, x to the fourth, and then it's going to be 7 to the third, and then it's going to be raised to the 1/3. I'm changing it to that so you could see. So if everything's being multiplied and divided as this is, then you could distribute the exponent to everything in there. So you're going to have 4, 3 to the 3, x, 4 to the 3, and then this one here is going to be 7, 3 to the 3. And so what this becomes is 4, there's one of them and then a 1/3 left over. So you're going to have x, and then you're going to have x to the 1/3, because when you add them, it's going to be 1 and 1/3, and that's what it reduces. Remember, the 4/3 becomes 1 and 1/3. Here's your 1, and there's your other third, and that becomes that, and then becomes 7. So your final answer is 4x over 7, and still inside is going to be, because that's the denominator, it is the index, it becomes x. So that's the long way, but I just wanted to show you that it distributes whether it's division or not. But the short way is just saying that it's the cube root of 4 to the third, x to the third, and then x to the 1 over 7 to the third. So that comes out, the x comes out, the 7 comes out, and you are just left with the cube root of x. And so that is your answer to that. Another problem, when you are multiplying these two, it's the same rule. So we have, hold on, let me move that up. We have the same thing here. that it's going to be, they're not indexes, the 4 and the 3, those are coefficients. So if I want to multiply them, then what happens is it's the same thing as multiplying the coefficients on there, and you get 12, and then you multiply the radicals inside, and so that gives you 16x squared. And so you could do this because everything's being multiplied. The little radicals get multiplied and the coefficients get multiplied. So you get 12, and then times, this is going to be 4, and then x, so you end up with 48x on there. So when you're multiplying radicals or dividing them, you could just go straight through to that and then simplify what they have in common. One thing that you could remember also is that if you have a cubic, then you could have negative numbers in there. So if the index is odd, then you could have negative numbers in there. And the reason being is because there are numbers, like say for instance the cube root of -8, that there is going to be, I could get -8 by multiplying -2 times -2 times -2, and that does give me -8. So if I do have that, that means that the cube root of -8 is just -2 because it reduces to -2. So the index here, there is no error here. You just have to actually multiply it through. But the 9 is not going to come out on there. Neither is the x, but you're going to multiply it with these two numbers and simplify it like you did over there. Let's see, so, yeah, you multiply the 9 times the 12 and you get the 108, and then, I guess we should do it since it's right there. So I have the cube root of, negative, 108, and then, x to the third, y to the fifth. And then, let's see, so this one's going to have 1, 2, 3. So, 3, let's see, times 4. So I think what you're going to have in 108 is going to be 27, negative 27 times 4. X to the third, y to the fifth. But 27 could come out, and that gives you a 3 out in front. So you're going to get a 3 out there. And you could have a -3 because that's going to give you -27. The x comes out, 1y comes out, and you're left with the cube root of 4y squared. I think I did the math right there. Okay, so same thing happens when you are dividing. It just reduces the same way. If we do a problem like this, 5, the cube root of xy to the fourth over the cube root of 25xy squared, you could rewrite it as 5 times the cube root of x to the 4, xy to the fourth, 25xy squared. And this is where you could reduce and simplify. I don't want to make this video too long, so you could just, reduce it in there and then take what they have in common out and then work from there. Let's see. So 3, if you're adding, that makes a huge difference. So you can't follow the rules the same way as if you're dividing or adding. In this case here, what you want to do is find, in order to add them, it's like you treat the radicals like a variable. This variable here has to be the same as this variable there. So you're trying to make the inside and the index to be exactly the same. So what you do here is, I guess it would be 3 would be 16 times 2. that's 32, and then this here is 25 times 2, and so I end up with 3 times 4 square root of 2, and then 2 times 5 square root of 2, and so that ends up being 12 square root of 2 plus 10 square root of 2. Those are both the same indexes, so it's like saying the same variables. They have to look exactly the same. There's 12 of the square roots of 2's, and this one has 10 of the square roots of 2, so together we have 22 square roots of 2. And so it's not the same as when you're multiplying or adding. And then the conjugates are really not too bad. So one of the things is that when we rationalize the denominator and there's a radical in there, you have to get rid of the radical. So when you're multiplying these, you're still doing the distributive process where you're distributing it over to everything, which is actually just multiplying. So I multiply the 4 and the 2 and I get 8. I multiply the 4 and the square root of 3, and so I get 4 square root of 3, and then negative 2 square root of 3. And when these two multiply, they come out because now you have 2 of them, and so it's negative 3. So you end up with the middle term, and so these two are like terms, so there's 4 of them and then negative 2 of them, so there's just 2 left over, minus 3. That is your answer. So you're just multiplying through. But when you have something like the conjugate on there, so like say for, oh, and just a quick note, if I have something like this, when there's 2 of them, that just means there's 2 of them. That's what the square is. So you say square root of 3 minus 3 square root of 2, and then 2 square root of 3 minus 3 square root of 2, and then you do the same thing we did over there where you distribute on there and then you multiply it out. And then the conjugate is really important. So the conjugate is when you want to rationalize the denominator. So when you have something like this and you want to simplify, what you do is you multiply the top and bottom by the conjugate. And by the conjugate, it means that you're going to do the positive of this. So you're going to have this here, and then you're going to distribute like we did up there. So what happens is that you have these quantities being multiplied to each other, and when I distribute, I'm going to get 3 square root of 5, and then this is going to be plus 3 square root of 2, and then minus, when you multiply, you can multiply those together, and you end up with negative square root of 50, and then minus square root of 20 all over square root of 25, and then minus square root of 10 plus square root of 10, and then minus square root of 4, right? So anytime that the bottom ones are exactly the same but different signs, those are called conjugates. And what happens all the time is that the middle term is going to cancel out. And then on the bottom, you're going to have 5 and then minus 4. On the top, you have 3 square root of 5 plus 3 square root of 2. And then there's a 25 in there, so 5 square root of 2, and then minus, there is a 4 in there, and so that's going to be 2 square root of 5 there. And so you combine, and now we could add, because they're going to be, I have 3 square roots of 5's and negative 2 square roots of 5's there, so I end up with square root of 5. This one here is going to be 3 of them, negative 5 of them, so 2 square root of 2 all over 1. So the answer is just 5 square root of 5 minus 2 square root of 2, and that is your answer. Okay, that should be it.